Everyone. So it's great to have you all here. This is Pi AI Hoyo. So this is part of the Pi and AI Hoyo, which is created to deepen conversation about machine learning and artificial intelligence concepts. It's a platform to network and learn from industrial experts. So I believe we'll learn a lot today. Today is all about end-to-end machine learning project development. We'll be touching on data preparation, exploratory data analysis, model building, model validation and evaluation, as well as deployment on with Flask and Docker. So a little background of our guest. He has worked with many firms, but he is presently the principal data scientist at OLX Group. He is the founder of Data Talks. I would still recommend to anyone to join that community because it's a great community to mix up with people who are interested in data science and related stuff. So he's also the author of Machine Learning Bootcamp. I would recommend you check it off. It contains projects that are beginner friendly. So he is also a competition master on Cargo. I believe most of us will already know about Cargo. So he will be sharing his experience with us, and I believe we will all enjoy what he has to offer us. So I will stop sharing my screen so that you can share yours.
Oh, thanks everyone. Thanks for having me. So thanks for introduction. I even forgot that I am a competition master at Kaggle. That was so long ago. So yeah, but that was fun. Anyways, so the plan for today is actually I have my book with me. So this is Machine Learning Bootcamp. And what I want to do is I want to cover 2 chapters of this book today, not the entire chapters. So there are like 9, but I want to cover 2 of them, which are machine learning for classification. So we will train a classifier model. And then another chapter is deploying machine learning models. So I want to show you how we deploy the model we just trained. So it will be a 2-part workshop. So in the first, we will do the classification thing, and in the second, we will do the deployment. Now let me share my screen. Okay, it works. And probably need to close some things. Yeah. I want to open this thing. Yeah, so that's the plan for today. I think I already talked about this. So we train a classification model for churn prediction, and then we will turn this model into a web service, and we will package it with Docker and deploy it to AWS. That's the plan for today. And yeah, so churn prediction is the process. So imagine that we work at a telecom company, a company that provides services, telecom services like phone, landline, mobile phone, internet connection, things like this, TV, I think also. And yeah, imagine we work at such a company, and then we have some clients, some customers. And then some customers are no longer satisfied with the services we provide, and they want to leave our company and go to our competitors. So they want to change their internet provider, for example. This is exactly what we want to do. So this is what we want to identify. We want to identify such users who are no longer satisfied with our services, and they want to cancel our contract and probably leave to a competitor. We don't really know. And the way we can use machine learning is we can look at the profiles of these customers and see maybe there is something that is common between those customers who decide to leave. And once we identify that somebody, well, then we train a model. And then with this model, we can see, we can apply this model to existing customers and see which customers who haven't canceled the contract with us, who are about to do that. And once we have that, we can then suggest some, reach out to these customers and suggest some promotion. So this is the use case we are going to cover today. And yeah, so you see that I use Windows. You probably do not see. Oh, now you see. So I'm on Windows, but I use Git Bash. Git Bash is a Linux-like environment. But I don't think there will be any operational system specific things today. And I think everything that I show you today will work on Windows, macOS, and Linux. But it for sure will work on Windows because this is what I use. Okay, and the first thing I want to do is I want to start a Jupyter notebook. So, and even before that, so I will use Anaconda. Let me open my browser and go to Anaconda. So Anaconda is a Python distribution. So they take Python and a bunch of packages, they put everything together and release it as a bundle. It's very convenient because it has almost everything that we need for data science. So to download Anaconda, you can go to anaconda.com, products, individual edition. And yeah, here you select like for whatever operating system you have, you select it. So for example, I'm on Windows, I will click on this thing and download it. Yeah, so I already did this. I do not need to do this once again. And now I want to start Jupyter. Jupyter is an interactive web environment for Python. I don't know how many of you already know this stuff, but just in case somebody doesn't know, I'm going to introduce the tool. And in Jupyter, we have this interface that allows us to write some Python code, something like print hello world, and it will execute this thing and reply back. So it's very interactive, it's very good for data science, it's very useful. So probably for you, Jupyter looks like that. Right? So for me, I remove the toolbar and just they have more space. Maybe I give it a proper name like hand2 and machine learning, something like this. And let me hide the header. So we will use this for training the model. And then the next thing I want to do is I want to find a data set. For that, I will go to the book repo. So this is my profile, and then I have it as a pinned repo, machine learning bootcamp code. And then we're talking about chapter 3. And here I have this data set. So in this data set, maybe we can already take a look. Okay, yeah, it doesn't do a nice preview. What I will do now is I will click on this row as a right click, copy link address, and then I will put it to, I will put this to a variable URL, and we have it. Right? And now I want to read this file. So this is a CSV file, and for reading the CSV file, I will use Pandas. Pandas is a library for Python for reading and processing tabular data, well, tables. PD. So this is how you import this. And then, so PD is alias for using Pandas. The version of Pandas I use is 1.3.4. I don't think it matters. Any version of Python would do. But, well, that is not 5 years old. But yeah, in Pandas we have this. I get a notification that somebody is in the waiting room, and I don't think I will be able to.
No, don't worry. It's over-ended.
Okay. Okay. Yeah. Sorry about that. Yeah, because I get these notifications and they're a bit distracting. So now we have this read CSV method, and we can use to download the CSV file from this URL, and then we will write it to a data frame. So now we have this data frame, and we have all this information we know about customers of our telecom company. So we have some meta information like customer ID, but then we have some demographic information about the customer, like their gender, whether they're senior or not, whether they live with a partner or not, whether they have kids or other dependents. Then we have some information about about how long they stayed with us, with the company. The tenure is the number, the amount, like how many months they have been with us. So for example, this person, she has been only for 1 month with us, and this person has been, he has been for like a couple of years. And then what type of services they use, like whether they use internet service, whether they use phone service, and so on. Then the type of contract, so there are multiple types of contracts like month to month, yearly, and 2-year contract. And then finally, how much they pay per month, how much they have paid in total over, like from the beginning till end. And then churn is if they decided to leave our company, to cancel the contract with us or not. So this is actually the variable we are interested in predicting, churn, if they want to leave or not. Well, it actually happened in the past, but using the past information, we can see what kind of people tend to leave, to churn, and then we can use this information to apply to people who haven't churned yet. So that's the main idea behind machine learning. So we want to use all this information that we have, like gender, like all this demographic information, all this, like how exactly what kind of services they have, in order to predict this churn variable. So this churn variable is the target variable. So let me take a note here. So we have actually, for machine learning, we have two things. So this is something we put to a machine learning model. So we have one, capital X. So this is a matrix. These are all the features. So these are all the characteristics we know about the users, about the customers, like this gender and so on, like everything except churn. So these are features. And then we have target variable. This is what we want to predict. So in our case, this is churn variable. And this is a binary classification case. So we predict yes or no. So we need to have a binary classification model. And yeah, that's exactly what we are going to do right now. So we are going to take churn variable, and we are going to use the rest of the columns, the features, in order to predict churn. Before we do this, I want to do a bit of preparation. So first of all, we do not need customer ID. I will remove it. So for that, I will use this del operator. So now if I print data frame again, it is gone. And then we see that there is some inconsistency in how the columns are named. Sometimes it starts with lowercase, sometimes it starts with capital case. Yeah, this is kind of not nice. So ideally we want to make it uniform, so it's the same, consistent. And we also want to do the same for the values, so for that it's all lowercase, and when we have spaces here, we replace them with underscores. So usually it makes things easier when they are consistent. So for that, I will just go to the repo and I will open a notebook. And by the way, all this code is available in this public GitHub repository. You can check it out. But what I want to do is I want to copy this thing. So this thing, I will execute it right now and I will tell you what it's doing, but I don't want to go into a lot of details explaining what each line does. So if you would like to know, you can check the book. But I executed this line, and you see that now everything is lowercase, and we replaced spaces with underscores. So the first line here is like making everything lowercase, and this part here, it replaces spaces with underscores. And the second line here finds all the columns that are strings. So for example, the senior citizen is not a string because I have ones and zeros. Monthly charges is also not a string. Total charges is not a string. So these are numerical values. But for example, payment method streaming movies, contract, they are strings. So first we need to identify them and then do the same thing like we did here. So we basically lowercase everything and replace spaces with underscores. So now it's consistent. Well, it's better. And what the next step is, we need to take a look at the types of the data. So object usually means that this is a string, and then integer, this is integer, and float, yeah, that this is a numeric with decimal points. So everything is fine here except these total charges. So for some reasons, this total charges is object, but it should be a float. So if we look at total charges here, we see that this is a number, right? So it's supposed to be, pandas is supposed to know that this is a number, but it thinks it's a string. And the reason for that is there are some things that are not numbers. We can take a look at them actually. Yeah, so right now I'm using filtering operator, so I want to show all the records that are equals to this. And you see we have a bunch of records for which we do not know total charges. So here we have like a placeholder, which is underscore. And yeah, and pandas thinks, okay, like this is not a number, I'll just treat the whole column as a string. And to force pandas to actually convert this to a number, we need to use this toNumeric function from pandas. And this is how we execute it, but now it will complain that I am unable to parse this underscore because this is not a number. I don't know what to do with this number. Yeah, let's just throw an error. In this case, we can say, you know what? I know that there are errors. Let's just ignore them. And for that, I think errors, we need to say that coerce. Probably, yeah. So right now, what happens if there is an error? It just replaces it with not a number, like an A, and now we can replace these NAs with zeros. And now, yeah, now it should be fine. And now if we look at data types, so monthly charges and total charges are both numeric, so they are both floats. Okay, so we did some preparation. Of course, ideally we should look into all these columns and then do some analysis, understand how they are, what they tell, like what are the important things, what are not important things. Unfortunately, we do not have a lot of time during this workshop to do this, so I will skip this part. So this part is called exploratory data analysis. So this is an important part, but here I just want to focus on the end-to-end process, and I will omit that part. Just 1 second. My kid decided to drop by and talk to me a bit, so now he's gone. Okay, so we will skip exploratory data analysis. If you want to learn more about this, you can again check the book. There I go into details about this data set and how exactly you can process that. How exactly you can do this. But yeah, for now we will skip that, and now we need to take this data set and split it into multiple parts. And now I'll just do a quick illustration. So this is our entire data set, right? So this is actually, let me check the length of this data set. So the length of this data set is we have 7,000 rows there. And what we want to do now is we want to split this. Let me make it look nice. So we want to split it into 3 parts. So we want to have a training part. So this is the part we use for training the model. Then we want to have a validation part. This is what we use for understanding if our model is performing well or not. And then we also want to have a test part. So this is what we use at the end for evaluating that our model is actually doing well. Well, I would just I'll just do these errors, meaning that we want to split it. And yeah, so this part, the train part, for us, let us take 60%, then validation part 20%, and then the test part is 20% of the original data set. So we use this for training the model, and we do not use this part for training the model. So once the model is trained, we apply it to this part, and then this is how we check that our model is actually doing well. So we apply it to the cases that the model didn't see. And let me quickly do this. So for that, I will use scikit-learn. Scikit-learn is a tool in Python for doing machine learning. And apart from implementing machine learning algorithms, it also has a bunch of utility methods, utility functions, and we'll use one of them. So from scikit-learn, model selection. So this is the module in scikit-learn that we will use. And there we have a train test split function. And this train test split function, what it's doing, it's taking a data set and splits it into two parts. So we'll split it into, first we will combine this into two, and then we do one more split. And this way we'll have three splits. So I will split first the data frame. Here test size will be 20%. We also need to say to fix the random split, the random state, because when we do this, we shuffle the rows of our data frame, and then we want to make sure that our results are reproducible. So if you run this and if I run this, we get the same split. So for that, we need to fix the state. And then we will have a data frame, I will call it full train, which contains both train and validation, and data frame test. Right, and now we need to do it one more time. Now we will take data frame full train and then split it into validation and train. And here we need to adjust it slightly. So 20% of 80%. So this part now is 80% of the original data set. But when we split it for the function, it is 100%. And 20% of 80% is 25%. If you're confused, just trust me, we need to put 25% here. And when we do this, when we look at our data frames, we check length, train, validation, and test. Yeah, we see that this way validation and test, they have the same length, the same number of rows, and then this is the part, the 60% part that we'll use for training. And this is how it looks like. So it also shuffled. You see, this is the index in the original data set, the row number. And yeah, so this is all the information we have about this customer. And then this is our churn variable. This is what we want to predict at the end. And one more thing. So we talked about this X and Y. So this X is a matrix and Y is a vector. And matrices, well, first let's start with Y. So Y is a binary variable. It should contain only zeros and ones, right? So 0 means no churn and 1 means churn. But here we have yes and no, right? So this is not something we can put in a machine learning algorithm because it expects a vector with only zeros and ones. And for that, what we can do is we can select like if a record, if churn equals to yes, then it's true. Otherwise, it's false. So we'll have like a series, like a vector monthly charges and total charges, which are numbers, we have a bunch of things that are not numbers. So like gender, for example, partner, dependents, and so on. So we somehow need to turn these values into numbers. And for that, what we can do is we can use a thing that is called one hot encoding. And I will quickly illustrate how it works. So for example, let's say we have gender, right? So let me make it larger. So we have gender. So like, I don't know, female, male, female, male. And the way we do this, we turn this column into two binary columns. So the first column will be gender equals female, and then the second will be gender equals to male. And the first will be 0, because for this record, the gender is female, and 0 here. And yeah, so for the second one, because this person is male, yeah, we put 1 here, and so on. You see, I have, for example, contract, which can be monthly, yearly, or 2 years. Let's say something like this. Well, 3 values here. We will have 3 columns. So we'll have contract, contract, which is monthly. We'll have 2 yearly contracts. One is 1. This one for this record, the 1 goes here. The name electronics. So something like when a wire has currency, then it's like a hot wire, and this is how this wire is encoded somewhere. So apparently those who came up with this name, they also were doing some electronics. I just want to check how much time we have. Yeah, so we want to turn, we want to use one hot encoding to turn these are called categorical variables into numbers. And then this is exactly what we are going to put into our machine learning model. And for that, we will use a thing. So again, in scikit-learn, there is a special thing for that. It lives in, I think it's in feature extraction, and it's called dictionary vectorizer or dict vectorizer. So this process of turning categorical things or just some things into vectors, this process is called vectorization. And this is exactly what we are doing here. So we have a bunch of categorical variables, and we are turning them into vectors, numbers. And then the first part here, dict, means that it works on dictionaries. But we do not have dictionaries, we have data frames. So now we need to turn our data frame into a bunch of dictionaries. So we will turn the first row into dictionary, second row into dictionary, and so on. And for that, in pandas, there is a method called toDictionary. And we need to say that we want to turn each record, each row of this data frame into a dictionary. And for that, we have a parameter, which is orient records. And I'll call this dict train. And we can take a look at the first 3 ones. So it turned the record, the row in our data frame, into a dictionary. Right? And then we see all the information about this record, right? And now we'll use this bunch of dictionaries to create a vector. So we'll use dict vectorizer for that. So it's dv. So we'll create a dictionary vectorizer. I will set one parameter here, sparse false. So this is just, so sparse matrices is an efficient way of implementing this capital X matrix when we have a lot of categorical variables. I will not go into details So that's why for simplicity, I will use sparse false here. And because I want to show you how this thing looks like, and this is easier to do it when sparse is false. So don't worry if you don't know what sparse is. And now I want to take this vectorizer and I want to apply this to our set of dictionaries. And the first thing I will do is fitting. So fitting here, this dictionary vectorizer will go through this list of dictionaries, and it will look. Let me print it again. But maybe first two. So it will look what kind of keys we have in these dictionaries, what kind of variables, and what kind of values we have. Like for partner, is it yes, no, and other things. So it will go through this list of dictionaries and it will learn how exactly it needs to vectorize this list of dictionaries. So this is the first step. And then the second step, now the vectorizer has trained, it has seen the dictionaries, and now we need to use this to turn our set of dictionaries, our list of dictionaries, into vectors. For that, we use this transform method. So we again apply it to the same thing, and this will give us this capital X matrix that we want. And let me show you how it looks like. So I will take a look at the first two rows. So now we have a bunch of, so this is the first row, and we have a bunch of numbers. And yeah, here we have a bunch of ones and zeros. This is exactly this one hot encoding scheme. And then for numbers, so this is like I think we have somewhere tenure, then total charges, monthly charges. Yeah, so for these variables we have numbers. Yeah, so now we have this X train, which is like our capital X, a matrix with features, with numbers. And then we have our Y train, which is a binary variable with zeros where people didn't churn and ones where they churn. And actually, I think I forgot one thing. So let me check if I do dictionary vectorizer, get column names, get feature names. It will show us what are the variables there. So what it exactly extracted. And we see that the first two are churn, no, and yes. And so effectively, if I train a model right now, I will use churn variable to predict churn, which is not exactly what we want to do. And the reason for that is because I forgot to remove churn. So I will do del data frame train churn. Okay, now it's gone, and I will need to execute it one more time. And now churn should be gone. Let me check it. I need to feed it. So feed it, and then execute this thing. Now churn is gone, and this is good. So now we can actually train this model. So this is the data we are going to use for training. And yeah, let me do this. So for this, we will use a logistic regression model. So this is a model for binary classification. In scikit-learn, it lives in linear models package. So we import this. And now we have our model, and we do logistic regression. We'll create the model first, and we do model fit. So we will train the model, and we provide this capital X matrix and lowercase y vector, and we just train our first model. And this model, yeah, so if we trained it, now what we can do is we can see how well this model performs, like if it's working well or not well. And for that, we need to repeat the same process as we did. We need to take our dictionary vectorizer and apply it to the validation dataset. So remember, we did this split. So we have the validation dataset that we will use for checking if the performance of our model is good or not. And yeah, so I will do this right now. So I want to do the same thing I did with train, but now I will apply this to validation. So first I need to get the variable, the target. And we will use that to see if the predictions that are coming from the model are actually correct. Then I will need to delete it from the validation dataset. And now I will need to turn the validation dataset into dictionaries. I'll call it dict_val or dicts. I don't remember how I'd call it. Yeah, it's a singular. And then I have this dict vectorizer transform. So I only need to call transform here, right? Because here, before that, let me remove this. So before that, I did both fit and transform, but I only fit this dictionary vectorizer on the training data. So I do not fit it on validation. I only apply it to validation. So data frame validation. Yeah, of course, because I need to, before I'm doing this, before I'm doing transformation, I need to turn this into dictionaries, right? Orient records. And then this is what I pass to the vectorizer and get X validation, the matrix. So this is how X validation looks like. This is the matrix. And now we will put this matrix to our model. So model predict. And I will put this here. And then I get a bunch of predictions. So 0 here means that for this customer, who is the first in this data frame validation, so for this customer, the prediction is 0. And for the last customer, the prediction is 1. We can also look at the actual values. So we see that the first person didn't end up churning, and the last person ended up churning. So we are actually correct. So the model is correct. So now we can see in how many cases the model was correct, and this thing is called accuracy. So we can evaluate the accuracy of our model. For that, in scikit-learn, there's a function for this. So it lives in scikit-learn metrics accuracy score. And we can just use that to check. Let me write this to ypred. It's short for predictions. And I will compare y validation with y predictions. And it says that the model is 80% accurate. And so we trained our model. We didn't do much there. We just put the data as is, cleaned it a little bit, put this to a model. So we used one-hot encoding there to turn this data frame into numbers. So then we trained the model. And then we evaluated this model, and this model turns out to be 80% accurate. So just 1 second, I need to get some water. Yeah, so, well, of course, you might be wondering, like, if this is a good model or not, like, is 80% is a good score? And apart from accuracy, there are a lot of other ways of evaluating the performance of a model, the quality of the model. I will not go into details right now, but yeah, you can check the book. In the book, I'm actually talking about this. So there is an entire chapter. It's chapter 4, which talks about evaluating machine learning models. Yeah, it's called Evaluation Metrics for Classification. That explains why accuracy is not always the best metric. But for now, we will leave it at this state. So we trained our first model, which seems to have a good accuracy. And what I want to do now with this model is I want to turn this model into a web service. And remember the use case I was talking about? The use case was that for people who has not ended the contract with us, who hasn't left the company yet, we want to identify if any of them are going to leave anytime soon. And if the model thinks that they are going to leave, then what we want to do is we want to send them some promotions. And for that, we need to take this model and package it somehow. So in such a way that we can actually use this and understand which customers are going to leave or not. For doing this, we will save the model and we will put this inside a web service. And then let me just illustrate it. So let's say we have like our model is here. And then let's say we have some marketing department. Let it be marketing. And then, so they will send a request to our model with some details about the customers, and then our model will reply saying, okay, I think for the customer you are asking, this customer is going to leave. And then this marketing department would send a promotional email to this customer. But if our model returns 0, it says that this customer is not going to leave, then marketing department will not do anything. So this is exactly what we want to do. So we want to put our model inside a service. So this will be like model service. And this is what I want to do now. So I want to quickly check how much time we have left, because I'm thinking if we should maybe have a break. It's for 1.5 hours, right? Okay, I'm wondering if I'm actually audible.
No, you are not.
That would be funny, like if I just
well,
like 40 minutes.
well, I suggest where we are presently. Does anyone have any questions with regards to what we have learned so far?
Because this is the end of the part 1, and then we'll have part 2, which maybe is more interesting. I don't know.
Okay. Can you unmute
so how
yourself?
much time do we have left? Oh, sorry.
It's actually planned for 1 hour.
Okay. So how much time do we have?
We
left?
have around 18 minutes. So you can unmute yourself so that you can ask your question. Maybe like 2 or 3 questions before we move on.
Okay. Hello, Alexey.
Yeah, hi.
Thank you. Yeah, thank you very much for the what you've showed us so far. I mean, that was a lot of things for me to even pick from what you explained. But the question I have in mind is, in a case where, for example, we have data that we do not know the customers who have churned from the company, but we just have a set of data points and want to kind of use unsupervised learning to solve this same problem. What do you suggest, and how do we even go about finding the accuracy for an unsupervised learning model if we were to use it in this case?
I would suggest to give up this idea of using unsupervised learning for that and get data. Just, I don't know, talk to your marketing department and ask people who leave and then get the data. Because with unsupervised learning, you're opening yet another kind of worms, and it's like enchanted territory. While in case of supervised learning, there are a lot of tools that are proven to work. So better invest this time instead of figuring out how exactly I use unsupervised learning. Invest this time into getting data about your customers and then use supervised learning.
Okay, thank you. And I have the second question on the one hot encoding which you explained. I saw that you were using dictionary vectorizers to kind of automate that. And previously I've seen like one method of that they actually write out like one hot encoding function, I think, to convert the columns that are like strange values into numbers. So like which ones do you advise us to like? Which one do you think works best for that kind of transformation?
Yeah, so I personally, what I do is I use count vectorizer most of the time.
Okay.
Vectorizer. Yeah, you can check it out. It's intended for using on text, but it can do the thing you described. So I will not go into details right now into how exactly to use this. But yeah, this is this is what I would use for that. Yeah, to be honest, I thought that we have. Thanks for asking. To be honest, I thought we have more time than 1 hour. I thought we have 2 because this is for how much I have time in the invite. But what I want to do right now is I want to quickly show you how we can deploy this model. I probably will not be able to cover the entire process of deploying this to the cloud, but at least I want to show you how to package it with Docker, put this in Flask, and if we have time, put this to Docker. So we have this model right now, and I want now to save this model. So I will do with, so we will use a model that is called pickle, which is used for saving things, any Python object. And with pickle, we can save model and dictionary vectorizer, because we will need both these things for later to be able to use the model. So we'll call this file model bin, and we need to open this file in writing mode and in binary. So W means writing and B means binary, because pickle is a binary format. And then F out. So here I use this way of naming the handle of this file. I clearly indicate that I will output something. So this is like a outputting, not reading. And I will do pickle dump. And there are two parameters that I need to specify here: the object that I want to save and where I want to save it. So as for the object, we actually need to save two objects. So the first is dictionary vectorizer, and the second is the model. And then where is this f out? And now if I check what we have in our folder, so we have this model bin. This is the thing we just saved right now. So we saved it. It's a binary file and it has two things. And now we can see how exactly we can apply this model to a customer for which, let's say, we don't know anything yet. So I will use a test dataset for that. So in test dataset, I will take the first row. So this is the customer. Of course, for this, in this case, we know that this, so she hasn't churned. I will turn this into a dictionary, and I will use this as the customer for which we want to predict if they churned or not. So I will of course remove this churn thing here. And what I want to do now is I want to restart my kernel. So when I do this in Jupyter, it's as if I start a new process. So everything I have done so far will be lost. And this is like I'm starting from a new process. So this is on purpose, because I want to show you how exactly I want to now apply the model. So I will do the first thing, I will load the customer, which I just specified, because this will be the customer we're going to use for testing. Now I will import the pickle model, and let me copy this thing. So now we need to replace a W with R. So R means read and B binary. And instead of F out, I will use F in. And the opposite of dump in pickle is load. And yeah, so we will load from a file F in, and we will, so this function will return us whatever it read, and it reads that this dictionary vectorizer and model. So now it loaded this. So we have our dictionary vectorizer, we have our model, right? And now we can apply this. So we have our customer, and we can take our dictionary vectorizer and turn this customer into a matrix, right? So this is a matrix with just one row. So this will be our X, right? And then we apply our model. We do .predict on this customer, and what we get is 0. So the prediction we make for this customer, for this particular customer, is that this customer is not going to churn. And I think, yeah, this is actually the case. So she wasn't going to churn, and our model predicts that she is not churning. So we will not send her a promotional email. And yeah, so this is how you apply it. And now let's quickly put this into a web service. So first I will create, so I'm using Visual Studio Code here. This is like a text editor. And I'll create a file, which I'll call predict.py. And what I want to do is I want to just copy everything we did here. So to this script. So import pickle, and then we open the model, and then we, so we do these steps. So we apply this customer to a dictionary vectorizer, and then we have Y prediction, and I just want to print it now to check that everything works well. So I turn this into a Python script, and yeah, so in this location, I will just execute now this predict, and it prints 0. Right? And yeah, there is a trick that I can do to get rid of these brackets. So this is a list with just one element. So I can add comma here. And when I do this, it gets the first element of this list and returns it. So when I do this, now it just returns 0. So instead of doing ypred 0, so I take the first element. So this is the prediction for this customer. We put this inside a Flask API. Now I actually, not yet Flask, inside a Python script. Now I want to turn this into a Flask API. So I want to create this service and put this in Flask. So I'll need to import a few things from Flask. So from Flask, I need to import Flask and I think request, 2 things. So now I need to create a Flask application. So it will be go away. So yeah, this customer, we do not need it right now because this is something that the marketing service will send to the model service. So we don't need this in this file right now. And now we create a Flask app, which we will call churn. And now we will need to create a function which we'll call predict, which we want to turn in a web service. And in this function, so we add this annotation app.root. So we just take a usual Python function and turn this into an endpoint in a web service. So something that we can send a request to and get back the response. And I think here we need to specify the root, like what exactly is the location of this method. And we need to say that methods, we want to use post method for this. So I will not go into details, so you can just go to the search engine and check post and get methods for web services, what they mean. And now we need to quickly get customer, right? And we do for request get JSON. I do not have autocomplete here, so I hope I don't make a lot of typos. And at the end, I want to return predictions. So then churn, and yeah, so I want to say if ypred is 0, then prediction will be no, and else prediction churn will be yes, right? And this is the prediction we put here, churn. So, and then I need one more thing before we can run it. I will go to the Git repo and copy it from there. So this, we need to go to this deployment chapter. And here we have this churn service, which is doing exactly what I show you. And I need to copy this part. So yeah, so this thing actually starts a Flask web service. Then let me do this, let me run it. Python predict. Yeah, it seems to be working. So what I will do now is I will get this customer and I will pretend that I'm a marketing service and I will send the request to this application. So, oops. I will go to the same notebook as previously and I will use a model called requests. So this is a module for sending requests to web services. And yeah, here we have our customer. And in the requests, I will use the post method. And then the URL where we will send a request is HTTP localhost, and the port is 9696. And then the URL is /predict. So this will be our URL. And then we will send this customer as a JSON object, customer. And we want to see the response. And for this, I will do .json to output the response, which will be here in JSON form. So let's see if it works. I hope nothing breaks. Yeah, cool. So now we sent the request. to a Flask application that has our model. So we scored this customer, and our model thinks that this customer is not going to churn. So we respond with no, and our marketing service now will not send a promotional email. Yeah, I don't know if I have time to show you more. Like, how much time do I have left? Because I also wanted to show you how to use,
I think we should take additional 10 minutes just for us to be able to do a little more.
Yeah, it's okay if I continue, yes? Okay, I treat this as yes. So we have this thing. Now I want to turn this into, I want to put this in Docker. And Docker is more like, it's sort of like a virtual machine where you can put different things, and then, yeah, it's like self-contained. It contains only the libraries that this project needs and doesn't have anything else. So for that, I will use Dockerfile. So this Docker file describes what exactly should be in a Docker image. And then it always starts with a from statement. So this is the base image that we want to use for our application. So in our case, let's go with Python 3.8. So this is what we want to use for, well, it already has Python. Yeah, we will just put our application there in this image. But if we just put it there, it will not work because it needs a bunch of libraries. And we need to install these libraries. And for that, we usually in Python, we use pip. And pip install will install this. And what I want to do now is I want to take a look at the other file I have, because just give me a second. Yeah, I just want to copy it because I already executed this thing, like this Docker file. And because I already did this a few days ago, it will be a lot faster because it will be using a cached version of this. Yeah, so we install three things here. We install scikit-learn, and this is the version I have. Like, let me do import scikit-learn. If I do sklearn version, so this is the version I have. It's a relatively, I think that's the newest version. So I specify the version, the exact version here. And this is important because this is, if it's not the exact version, when we try to unpickle our model, we might have problems. Then we put Spark or Flask. We'll put Flask here. We don't care about the exact version of Flask. Actually, it's a good idea to put the exact version, but it's okay if we don't here. And then the last thing is JUnicorn. So JUnicorn is a thing that can run Flask applications. And the reason we need JUnicorn is if we go to our terminal where we run Flask, we see this big warning. So the warning says, this is a development service, do not use it in production deployment. So Flask is not, well, it says use a production VSGI server instead. So Flask is not a production VSGI server, but JUnicorn is. So JUnicorn can run Flask applications, and this is a production VSGI server. So it's not really important what is a VSGI server is, but this is just how we run Flask in production. And now we need to copy things from here. So we have our model and we have the code. So we need to put them in Docker image. And I will do that now. So model bin, and then predict.py. So first I write the files I want to copy, and the last argument here is where I want to put this. So I put dot here, meaning that I want to put them in the current directory. And actually one more thing, we need to specify what the current directory is. In Docker we do using workdir, and then we can just put it to /up. So and the current directory is, let's say, where I run this thing. So if I do pwd, it shows me where I am right now. So we want to sort of do cd change directory to this directory, and then copy things there. And once we have that, we need to tell Docker how exactly we want to run this predict.py. And then again, for that, I will need to copy these two things. I will explain what I'm doing here. Yeah, so this thing is how we run Flask apps through JUnicorn. So we say, hey, JUnicorn, I want to go to this predict.py file. So that's why we write predict. And then I want you to find a variable called up. So this is this thing, up. And I want to start serving it on port 9696. So this is what it's doing. And then this line is also important. We say that on this Docker container, the port 9696 will be open and there is a web service living on this port. So please open this port. And now I saved it. And yeah, I think what I need to do now is just execute it. So I'll do docker build -t, and then I need to specify the tag name. So how exactly I'm going to call this image. I'm going to turn churn service. And then I put dot. Dot means that I want to look for a Docker file in the current directory. And in the current directory, we have a Docker file. So just hit enter. And yeah, so this is not the best font, but you see that it says the result is cached. So when I run this, I run pip install scikit-learn and so on. So yeah, because I already did this, so it just reuses the results that from the previous runs. And this is very convenient because I don't need now to spend time on installing these libraries. So now we can run this with Docker. So I'll do docker -it. This is interactive mode, --rm, meaning that I want to remove the image after running. Then I need to specify the image, the name of the image. And before that, I also need to specify the port. So did I stop it? So I need to stop this thing here. Yeah, okay, I stopped it. So I want to say that I want to run it on port 9696. And I want to connect it to the port 9696 of the host machine. And the host machine is my laptop where I'm running this thing. And then inside the Docker container, the port is also 9696. So I think that should be sufficient. Now it should hopefully start. Yeah, so we see some logs. So it is running in Docker. And if I execute the same thing right now, I get the same answer. So this is cool. I don't see, unfortunately, anything in the logs, so they are not very verbose. But yeah, now, because I stopped this thing, so this thing is no longer working, now the request went to this Docker service. Okay, I wanted to do one last step of showing how to deploy to AWS. This is relatively fast, so maybe I'll just quickly show you. So I will use a service from AWS called Elastic Beanstalk. And for that, I need to quickly look up how the command I need to use looks like. So we need to first install this. Yeah, I lost it. So let me, you know what? Yeah, cool, I found it. It's convenient. So this Elastic Beanstalk is a service from AWS that we can use for deploying web services. And for using it, I need to install a Elastic Beanstalk CLI. Let me see. It's AWS Elastic Beanstalk CLI. So I need to install this library. Pip install. I already have it. And then I write EB. So this is a library that comes when I do pip install this thing. I need to do initialize. And then -p, I need to say what the project type is. I'll say Docker. And then I'll do churn service, the name of our service. So now it creates a Elastic Beanstalk project. And here, yeah, if we do ls-a, we see that there is actually a new folder, Elastic Beanstalk. I want to go to this folder and open config YAML. So this is the configuration. And yeah, here the region where it will be deployed. And I want to replace because I am in Europe. So I'll deploy to EU West 1, which is Ireland. Yeah, and now I can test things locally. So for that, I can do eb local run and then port 9696. So now it will do the same thing as we did with Docker. So it will now try to build the Docker image. Yeah, you see, and basically it's doing the same thing as we did previously. And now if I go here and run this thing, yeah, it goes now to this thing running locally. And to deploy this thing to a cloud, I do eb create churn service env. And then now it will take like 5 minutes to actually deploy. That's why maybe let's use this time for questions. If there are questions. I see that there are 29 comments.
Yeah, I shared the link to the Git repo and the link to the book. So for anyone that is interested. So I will recommend that everyone should check the public repo in order to further learn about all we have been talking about. So if there is any other question, you can signify or drop it in the comment.
For now, I will stop sharing my screen. How do I actually do this? So, no questions?
Yeah. Well?
Yeah, because this thing,
I believe
yeah, I wanted to show you how to actually, well, how to query Elastic Beanstalk. So maybe give me one moment. I will just say what you would do if, what I would do if I had 5 more minutes. So at the end of this process, there will be a link, and you take this link. So it will be a URL. You take this link, you put this to this URL, and you add /predict, and then you execute the same thing one more time, and then you get a request from, you get a response from Elastic Beanstalk. So it's as easy as that. You just need to do eb create and the name, and then it takes some time to deploy this, but then at the end you have a service deployed to the cloud. Yeah, so it's doing some things right now. But yeah, if I had a bit more time, you would be able to see this. But yeah, maybe this is something you can do as a homework.
Yeah, there is a question from the comment. Does the book cover model deployment?
Yes, it does. There are like 3 chapters about that.
Okay.
So what I showed you today is in the book with more details, because here I couldn't really go into details what each line in Docker file is, but there I do that. Well, I also explain what Docker is and why we need this. And then I also show how to, in another chapter, I show how to deploy to AWS Lambda, which is a different way of deploying things. And then I talk about Kubernetes in the last chapter.
Okay. So what will be your advice for people who want to learn more about all these concepts, model deployment, model creation, EDA, and all that? How will you advise that they go about it?
I mean, yeah, one very shameless advice is this book. Right? Then there is a course that I think you sent a link. So this is a free course. You can take it. You don't have to pay. You will learn that. But probably your question is more like how to learn these things in practice, right? And there is no easy way to do this except practice. So just go and find a data set, play with this data set, try different models there. And then don't stop there. Don't stop in your Jupyter notebook. Go outside of your Jupyter notebook, create a Flask application, deploy this Flask application somewhere, like Elastic Beanstalk. And maybe, so I want to take another minute because this thing actually is deployed. So you see the application available at this URL. And I will copy this link. Now I will put it here. And I will execute this, and you see, so this is the URL I used. So we were able to successfully deploy this thing to the cloud. And now the marketing department can use this thing and to decide who to send promotional emails and who not to send. Yeah.
There's a question from the chat, which why didn't you use EC2 plus GitHub? Should we use a fast API versus Flask?
Yeah, up to you. Like whatever floats your boat. If you like fast API, use fast API. I don't think there is significant difference between the two. Yeah, up to you basically. If you like it, use it. I like Flask. I use Flask.
Okay.
Yeah, no particular reason for that.
Yeah.
Then the other thing you said about EC2 and what? GitOps?
Yes.
Yeah, well, you can use it. Yeah, if it's something that works for you, go for it. But yeah, so here I showed how to use Elastic Beanstalk, and the reason I decided to go with Elastic Beanstalk for this session is because it's just 2 commands. So first you initialize a Elastic Beans project, and then the second command is you deploy it.
Okay.
Assuming that you have a Docker file there, it's just that, right? Of course, you need to wait for a couple of minutes before it's available, but it's quite simple. So
Okay.
I like it.
Yeah. I guess this should be the last question. Will using random forest classifier make a difference?
Yeah, maybe not. So it's really like there is no free lunch in machine learning. Maybe you heard this. So each data set is different, and you never know if using random forest will make a difference or not until you try. So you have to try it. You have to set up this cross-validation framework that I showed. You need to split your data set into multiple parts. Then you train your logistic regression, you train your random forest on the training part, and then you check the performance of these models on the validation part. And if random forest on the validation part gives a better score, then go with random forest. If it doesn't, then go with logistic regression. And there are data sets where logistic regression outperforms random forest. Most of the time, actually, random forest is better. So probably yes, random forest will make a difference here. So probably it will be a bit better. But again, it's case dependent.
Okay. Thank you very much, everyone, for being here. It's really a good session. I believe we have learned one or two things from the wealth of experience of Alexey. So thanks very much for being here. We are, I believe you take this experience and the knowledge shared today to you push it further for yourself.
Yeah.
Thank you very
Thanks
much,
for having
everyone.
me. Thanks for having me. Sorry that it took a bit more time than.
No.
But I
It's
hope
for
it
the
was
greater
useful.
good, I believe. All right, everyone.